Our today's topic is finding confidence interval for population mean. So I will talk about the basic stuff such as calculating the point estimate of a population mean, calculate and interpret the Z interval for the population mean when the population is normal and the sample size is large. Find ways to reduce the margin of error, calculate the sample size needed to estimate the population mean. So what is point estimation? If we do a survey and find a mean for a smaller sample and then use that mean to predict the data for the entire population, then we call that process a point estimation. So what is our basic perception? Our basic perception is we will be given with a sample mean and we would like to use this sample mean in order to give a range for the population mean. So the point estimate is called the information that you gather from the sample. So if it is a mean, then the point estimate in that problem is the mean. So confidence interval is a range which is symmetric about the projected population data. We are going to use the Z interval to find the population mean under the situation if the population is normally distributed and the population standard deviation is known. So first of all, you have to make sure it is normally distributed and population standard deviation is known, or the sample size is large enough and the population standard deviation is known. So if you do not know that it is a normally distributed distribution, but you know that the sample size is large enough, it's greater or equal to 30, and the standard deviation for the population is known, you can find the Z confidence interval. So we will talk about only Z confidence interval in this lecture note, and we are going to learn the process of finding the Z confidence interval. To find the confidence interval, the first information I need is the point estimate. What is the point estimate? The point estimate for the confidence interval of the mean is the sample mean. So I will say the point estimate is X bar. Every confidence interval is dependent on the level of the confidence. So when the level of the confidence is given to you, you will be able to use that in order to find out the required alpha. So how do I find it out? What will be the required alpha? Well, in that problem, I should be given a confidence level. Once the confidence level is given to you, what you can do, you can use that in order to find the level of confidence or alpha. So say confidence level is 95%. So I want to be 95% confident on my work. What will be the alpha? If this is the confidence, you subtract 95 from 100. And then you divide this number by 100. And the value you get is called alpha. Depending on each of these alpha, we are going to find out half of alpha. So we're going to find alpha over 2. And alpha over 2 is the area to the left of a z-score. And that z-score will be called z alpha over 2. Once you find and recognize the z alpha over 2, you are going to use the population standard deviation sigma, divide it by the square root of the sample size, and you will get sigma over square root of n, and multiply that with your z alpha over 2's absolute value. And then you are going to add and subtract this from the point estimate, and you will get the confidence interval. So we are going to execute all of this work in 2 phases. First, I'm going to show you how to do this work manually, and then I will show you. Okay, so let's carry on. The next topic that we see is the margin of error. The margin of error is simply the number E equal to the Z alpha over 2 value we found out multiplied with the standard deviation of the population divided by the square root of the sample size. We will learn how to find it and how to interpret this number. So there is one other topic that I want to discuss, but before that, let's go ahead and start solving some of the problems. So the next one says the problem, find the point estimate of the population mean, calculate sigma over square root of n, find z alpha over 2 for a confidence interval for the indicated confidence level, construct and interpret the confidence interval with indicated confidence level for the population mean. So we're going to answer all 4 of them. So let's do a problem by hand first. This is about consumption of carbonated beverages. The US Department of Agriculture reports that the mean American consumption carbonated beverage per year is greater than 52 gallons. A random sample of 30 Americans yielded a sample mean of 69 gallons. So I will say the sample mean X bar is equal to 69 gallons. And this has come from a sample size of 30 Americans. The standard deviation is for population, so sigma is given, so we're good. Sigma is 20 gallons, and the confidence level is 95%. So confidence level for this problem, first one, is 95%. So we pretty much have all the information. Now first, note that the sample size n is 30, and I wanted it to be greater or equal to 30. It is, so check. Population standard deviation is 20, that is given, so check. So it makes sense to do the Z confidence interval. The first question asked you, what is the point estimate? So the point estimate, as I said, is the sample mean. So I will go ahead and say that the point estimate is X bar equal to 69 gallons. The next question is asking us to find sigma over square root of n. Our sigma is equal to 20 and square root of n will be square root of 30. We're going to find this number in our calculator and round to 4 decimal places. Let's go to our calculator and we will say 20 divided by square root of 30, rounding to 4 decimal places, it is 3.6515. 3.6515. The third question is find Z alpha over 2. If you look at the list of questions that we have been asked to work out, is finding Z alpha over 2. The Z alpha over 2 will be found in a way using the confidence level. So since the confidence level is 95% for this problem, we will say alpha is 100 minus 95, and then I am going to divide it by 100. That's the formula. So you will get 5 over 100, which is 0.05. So alpha over 2 is equal to 0.05 over 2, which is 0.025. Now remember what I told you when I'm finding Z alpha over 2. What is Z alpha over 2? Z alpha over 2 is the Z score, so that the left of this Z score is going to be alpha over 2. In our problem, the alpha over 2 is 0.025. So we'll go ahead and see the standard normal table in order to determine the Z alpha over 2. And I will say whenever you find this value, it will be a negative value for every single problem. But we are always going to write the absolute value of that negative value. So let's see how much is the Z alpha over 2 value. In order to do so, if it helps, draw the little curve of yours. And you say that I want to find this thing so that the left area is alpha over 2, which we found as 0.025. So we're finding the area 0.025 from the standard normal table. So let's go to the standard normal table, and that will be under table 0.025, and that's there. The corresponding Z-score is negative 1.96. So as I said, we will use the absolute value of that. So it's negative 1.96. But when you are writing Z alpha over 2, You take the absolute value of this number, which is always going to be positive, so positive 1.96. That's what I'm going to use in finding the confidence interval. How to easily do so? So first find, that's your fourth question, find and interpret the confidence interval. Find the margin of error. The margin of error is equal to z alpha over 2 times sigma over square root of n. And see, I found both of these values. Z alpha over 2 is 1.96, and I'm going to multiply this number by sigma over square root of n, which is 3.6515. And I will multiply them and round it to the nearest 4 decimal places. So go to calculator. I will say 3.6515 times 1.96, which is 7.1569. 7.1569. The confidence interval is denoted by I, and it is equal to the point estimate that you found out. Point estimate is the sample mean, so 69, minus the margin of error, which is 7.1569, comma, the point estimate 69 plus 7.1569. So we're going to simplify these numbers. When I subtract 7.1569 from 69, I get 61.8431, comma, then I add and I get 76.1569. So this is the confidence interval. And how do I interpret that? What does it mean? It means if the sample mean, so remember your entire process of point estimation, if the sample mean of 69 gallons is used to estimate the population mean, then the population mean mu will be in the interval of confidence. So we found the confidence interval, and it will be in the interval of 61.8431 to 76.1569, and we are 95% confident about that, with a confidence of 95%. That's how we're going to interpret the confidence interval. Compute and interpret the margin of error. So we found the margin of error. The margin of error is E, which is equal to 7.1569 gallons. Interpretation is pretty similar to the interpretation of the confidence interval. We say that if the sample mean of 69 gallons is used to estimate the population mean, then the population mean mu will be the margin of error 7.1569 gallons plus or minus of the 69 gallons, which is the sample mean. So it will be around 69 gallons, and it cannot exceed the margin 7.1569 gallons at a confidence of 95%. And that answers your question. The next couple of questions, in order to answer them, we have to go back to page number 1 and talk about the sample size requirement. So what it is telling you, the sample size requirement for estimating the population mean is given by the formula n equal to z alpha over 2 that we found out times sigma over the margin of error given square. And this one you will use if you know sigma. So let's try to answer our question now. Our question says for part B, how large the sample size should be in order to estimate within 25 gallons with 95% confidence. So we already know if the confidence is 95%, then Z alpha over 2, we found it, and that's 1.96. Remember we said that we are going to use only the positive value of the Z alpha over 2 value. The margin of error, because I want to make it accurate within 25 gallons, is 25. So I will use them in the formula. So n is going to be, the required sample size is going to be, if you use the formula, it's Z alpha over 2 times sigma over the margin of error. So we're going to put those information in. So Z alpha over 2 is 1.96. The sigma we found out is 30, and I'm dividing it by 25, and then I squared it. So it might not be a whole number. Our suggestion is round up to the nearest whole number, and I said round up, so always round above. So let's see how much this is going to be, and I have to use my calculator in order to work it out. So we do 1.96 times it by 30 divided by 25. So I get 2.352, so 2.352, and then I am going to square it. So I will get 5.5319. So n is approximately equal to 5.5319. I will round it up to the nearest whole number, so that will be 6. So I will need a sample size of 6 people in order to make sure the margin of error is within 25 gallons. The next question asking me, what should be the margin of error, sample size if you want the margin of error is, now I'm making it smaller, within 5 gallons. So pretty much same work, still 95% confidence, so Z alpha over 2 did not change. So I will say that, well, Z alpha over 2 is still 1.96. Sample standard deviation, population standard deviation is still 30. So those information did not change. The only changed information here is the margin of error, which is 5 gallons. And I'm going to use them in order to find the sample size. So that will be 1.96 times 30, which is the population standard deviation, over margin of error is 5, and square it, round it up. So again, we're going to use the calculator. I do 1.96 times 30 divided by 5. So I get 11.76, and then I'm going to square this number. So that's 138.2976. So this is 138.2976, and you will round it up to the nearest whole number, so that will be 139. So a sample size of 139 people will be required in order to make sure that the margin of error is within the margin of 5 gallons. That answers the question. So this is pretty much what we are referring to when we are doing Z confidence intervals. So what I will show you how to skip all this work by hand. I still have to interpret in the proper way and use Excel spreadsheet in order to work these problems out. So we'll go to our next problem and try to catch up. This is about Latino tobacco consumption. The Bureau of Labor Statistics reported that the mean amount spent by all American citizens on tobacco products and smoking supplies was $308. The mean for American Latino is $177. Assume that the standard deviation for American Latinos equals $150 Assume that the data of American Latinos represent a sample size of 36. The confidence level is 90%. And we're going to answer all 4 of those questions that we have answered in the last problem. So what are the information? So first, I will say point estimate. Point estimate is the mean amount spent by American Latinos for the sample. So I will say point estimate is $177. Now see, the sample size being 36 is greater than or equal to 30, so that checks out. Population standard deviation is given to you, and that's 150. So we're good in both of them. It is given. So I will use the Z confidence interval. Second question is finding sigma over square root of n. Third question is finding Z alpha over 2. And the other information given to you is the confidence level. So the confidence in this problem is 90%. And then I'm going to talk about the confidence interval. And I'm going to show how to do this work in Excel spreadsheet and gather information from there. So again, we will go to our class folder and we will pick Excel spreadsheet. I am doing Z confidence interval, so look for that and see how it says mean Z confidence interval. So click on that. It tells you what are the blocks that you're going to fill in. So if you go there, it says change the confidence level. The confidence level is in B3, that's 90%. Then it says mean in B2. So the sample mean for this one is in B2, 177. Then it says sample size in B1, which is 36 for this problem, and population standard deviation in D2. Population standard deviation is $150 for this problem. If I go back to the problem, these are the numbers we have been given. And it has calculated everything for you. So if I look at the Z alpha over 2, it has given me the value is negative 1.644853627. I will just use this number rounded to 2 decimal places, but I will write the positive number. So it will be 1.64. So that's first answer, Z alpha over 2 and sigma over square root of n. Sigma over square root of n is going to be 25. So I will say sigma over square root of n is 25 from the spreadsheet. No work. I just find the information from the spreadsheet. This is 1.64. The spreadsheet will show you the negative value. Always write down the absolute value, the positive one. Confidence interval. It has found out the margin of error and confidence interval as well. In fact, it kind of does the interpretation too. So when I talk about the confidence interval, you see here, we are 90% confident if we use the sample mean to estimate the population mean, then it will be within the margin of negative 41.121 to 41.121. And the confidence interval I is from 135.878659 to 218.1213. So round both of them to 4 decimal places. So I will say 135.8787. So 135.8787, comma 218.121. That's your confidence interval. The interpretation, I'm going to just copy and paste. So let's go ahead here and we are. So let's copy and I'm going to just paste it here. So sorry, let's get back. So it didn't let me copy it very well. Let's just go ahead and write it down. So we will say, because the confidence level was 90%, your interpretation of the confidence interval will be, we are 90% confident that if the sample mean of $177 is used to estimate the population mean. Then mu, the population mean, will be in the interval $135.8787 to $218.121 answers your question. And then similar type of question, compute and interpret the margin of error. We found the margin of error if you look at the spreadsheet, and we will do it. So the margin of error in this situation from the spreadsheet, we're looking for E, and that's 41.1213. So we'll go ahead and say that margin of error is E equal to 41.1213 and interpret that. So we'll say we are 90% confident. So pretty much the same language that you have used for the interpretation of the confidence interval, that if the sample mean of $177 is used to estimate the population mean of mu, then it will be within a margin of the margin of error. So 41.1213. The last one I said it will be plus or minus the margin of error of the sample mean. I can also say it will be within a margin of $41.1213 from the sample mean, or of the sample mean of $177. That is the interpretation of the margin of error. Second question, how large the sample size would have been required if the BLS had wanted to estimate the population mean amount spent by American Latinos to within $50 with 95% confidence. So now you want Z alpha over 2 for 95% confidence. So it will be a little changed. So I will not do any work here. I will go to the spreadsheet and change the confidence interval to 95%. And that is going to give me Z alpha over 2, which we are going to use in order to find out the required margin of error. So in fact, if you go to the spreadsheet, it will show you the calculations for the required sample size. So this one, according to our problem, we want it to be within $50. So I will just say this is $50. And then go ahead and change the confidence level. It is 95 for this problem. And all I need is that much. It has given you the estimated N. Remember, I'm going to round it up to the nearest whole number, so that will be 35. So I will say that for the second part, sample size required will be 35. And it will answer your question. The next one, number C, is asking you how large the sample size needed to be if the BLS had wanted to estimate the population mean amount spent by American Latinos to within $10 of the 95% confidence. So I want to do that problem, but it is even better margin of error. I want to do it for $10. Confidence level is still 95%, so don't have to change anything in the confidence level section. But the margin of error is $10. So we'll go ahead and change it, and it will tell me the sample size. So round it up, it will be 865. So you will need a sample size of 865 people. So this time doing the work for 95% still, but the sample size needed is much bigger. So sample size needed is 865. If I remember the number right, absolutely. Answers my question. Let's see what else we can do. So this is a very famous problem. It is about short-term memory. In famous research paper in the psychology literature, George Miller found the amount of information humans could process in short-term memory was 7 bits piece of information, plus or minus 2 bits. So this is 7 plus or minus 2. Remember how I write the confidence interval. That is huge importance on this problem. Let us assume that the title of Miller's paper, the magical number 7 plus or minus 2, refers to a confidence interval. So this is a confidence interval. Remember, the confidence interval is the point estimate x bar plus or minus e. And that tells you the point estimate x bar, or the sample mean, is 7 and the margin of error is 2. Let's see whether we can answer the following question. What is the point estimate for the amount of information all human can process in short-term memory? Well, we have answered it. It's the sample mean, and that is 7 bits of information. Second question, what is the margin of error? Interpret this number. Margin of error is 2, and we will say we are certain percent confidence, but the percentage is not given in this problem. If the percentage is not given, by default we are going to assume it is 95%. So I will write it down so that you remember. 95% confidence is called the default confidence. So if I'm not giving you the exact confidence level, it is 95%. So we are 95% confident that if the sample mean of 7 bits is used to estimate the population mean, then mu, the population mean, will be within a margin of 2 bits, the margin of error, from the sample mean of 7 bits. And the next question is telling you the most common confidence level in the psychological literature is 95%. Which value of z alpha over 2 is associated with 95%? So this is going to come directly from your spreadsheet. Just make sure the confidence level in the spreadsheet is 95%. It doesn't matter what other information are there. So I see that the confidence is 95%. So z alpha over 2 is going to be positive 1.96 rounded to 2 decimal places, and the positive value for this number is 1.96. will answer my question, and that's precisely what we wanted to talk about, the z confidence interval. So the thing that I want you to understand at this point, I have used z confidence interval if I knew either the distribution is normal and the population standard deviation is given, or if I knew that the sample size is more than or equal to 30 and the population standard deviation is given. So if one of these two conditions were not to happen, I cannot use z confidence interval. So next time what we will talk about is t confidence interval for the mean, and we will see if sigma is unknown, the only way of answering question at that point is finding the t confidence interval. So I will stop here today, work on your assigned problems. Let me know if you have any further questions. I will get back to you as soon as I can.